So in this next Algebra 2 lesson, we're going to be working backwards with functions. So what does that mean? Well, sometimes we want to work in reverse order with functions. That means that we know the particular output value we would like to have, but we want to know which x values will generate that. So a question such as, for what x value does the function f of x equal 12, means we're working backwards. So let's suppose we're given a function f of x equal to 1/2 x squared minus 1. And we say, for what value of x is f of x equal to 1? Well, we're working backwards. We know the output is 1. We want to know what x value has to be input. So what we do is we replace the f of x in the function definition with the value that we want it to be equal to, which in this case is 1. So for problem number 1, we're going to say 1 is equal to 1/2 x squared minus 1. We simply replace the f of x with the number we want it to be equal to. Now this is a regular equation. We solve it like we do all our algebra equations. Get like terms together. Then we want to isolate the variable. So first let's get rid of the coefficient. We can multiply both sides by 2. And we see that 2 times 1/2 is 1, so they cancel each other out. 2 times 2 is 4, so we have 4 is equal to x squared. And now we're going to introduce a square root. And the square root will cancel the square. But anytime we introduce the square root, that symbol, it wasn't a part of this problem originally, we introduced it, we have to consider both the positive and the negative values that can come from that. So what that means is that x is either -2 or x is +2, because -2 squared is 4 and +2 squared is 4. So we have two possible outputs. So it says for what x value is f of x equal to 1. So let's just put our answers here. It will say x equals plus or minus 2. That means we have two different answers. So we want to do this all again for question number 2. We're going to say, let's set f of x equal to 7. So once again, we took that f of x and replaced it with the value we want it to be equal to, and we solve as we normally do. So we're going to add 1 to both sides. We have 8 is equal to 1/2 x squared. And just like before, we're going to multiply both sides by 2, because that's the reciprocal of 1/2. It'll cancel out that fraction. We have 16 is equal to x squared. And when we take the square root of both sides, we get plus or minus 4 is equal to x. And now we can do this one more time for question number 3. We're going to replace the f of x with -1/2. So we have -1/2 is equal to 1/2 x squared minus 1. We're going to add 1 to both sides. -1/2 and +1 give us a +1/2. And when we divide both sides by 1/2, or if we multiply both sides by 2, then we're left with 1 is equal to x squared, which means plus or minus 1 is equal to x. So now we're asked to express our answers as ordered pairs. And if we go up above, we see, well, we had plus or minus 2 would get paired up with 1. So it means we have -2, 1, and we have a +2, 1. That means we had two ordered pairs for question 1. The same thing for question 2. The x value was either -4 paired with 7 or +4 paired with 7. And for question 3, we have that either -1 is paired with -1/2 or +1 is paired with -1/2. So now we could also do this if we didn't have an equation representing the function, but instead we had a graph. Here we see we have the graph of g of x, and it's asking us, when is g of x equal to 1? So we go to the y-axis and we find 1, and we go left and right looking for what points or what x values will generate that 1. And we see that this is true for x equals -2 and for x equals +2. And we'll do this again for each of these. For what x value is g of x equal to 0? Well, we find 0 on the y-axis. There it is. And we see that there's only one x value that does that. So we only have one ordered pair. And now I'm going to erase all of this so we can do the next one. And we're going to approximate when is g of x approximately equal to 1.5. So we go up to 1.5 and we say, well, let's look left and right of that and let's approximate that location on the x-axis. And we see it's approximately 2.5. And if we go to the left, we can do that same thing. We say it's approximately negative 2.5. So x is equal to plus or minus 2.5. And then finally, we express our answers as ordered pairs. So we have negative 2 comma 1, positive 2 comma 1. For question 2, we only have one ordered pair, and that's 0, 0. And for question 3, we have negative 2.5 comma 1.5, and then we have a positive 2.5 comma 1.5. So that's the end of our presentation. Go through the video, take notes, do the practice. Let me know if you have questions in class.